for coming to today's speaker series. Today we have John Resig. You know him best as the author of jQuery, the book Pro JavaScript Techniques, and he's also the writer of the RSS to JSON converter that we have on YDN. You guys doesn't know that. He is a graduate of RIT and comes here today from Cambridge to join us. He's also a man of many interests, besides JavaScript, of course. He has an interest in Perl, data mining, and not making movies. He's even started several companies back when he was in college. The guy can do everything, basically. So please join me in welcoming the multi-talented John Resig to Yahoo.
Thank you. So today I wanted to do a quick talk on JavaScript libraries and sort of my experiences, the experiences that I've had in developing a number of different JavaScript libraries. So I come here today in two different capacities. One, I work for the Mozilla Corporation in developer relations, and I work on a number of projects there relating to JavaScript and JavaScript libraries. Specifically, the one project, a big project I'm working on right now is called Fuel. It's a JavaScript library to develop extensions. It's going to be included in Firefox 3, and it's designed to reduce the complexity of extension development. It's currently pretty daunting. And the other thing is I'm also working to integrate the test suites of JavaScript libraries into the Mozilla test suite, such that if there's ever regression in Firefox, we'll know about it and be able to fix it immediately. Additionally, I'm also the creator and lead developer of the jQuery JavaScript library. It's been around now for just over a year. And generally speaking, its goals are to have a small file size, be able to write, be able to enable the developer to write really short, concise code, and while providing a good base to be extensible with plugins. So I wanted to just show you my perspective on what I feel that libraries are. Effectively, I feel that libraries are generally an abstraction away from a current API. In the case of most web development and most JavaScript libraries, libraries provide an abstraction away from the DOM APIs that exist. However, these libraries give us new APIs to interface with. So effectively, any time you create a new library, you're introducing a whole new set of APIs. And if there's a library building on top of a library, it's just another set of APIs that you just keep building on top continually. So sort of something that I've come across here in developing JavaScript libraries and in the users that use them, sort of forming a hypothesis, if you will, in that I'm finding that the APIs that users are presented with and the APIs that users use, they breed specific patterns based upon how the API is constructed. Libraries built on top of an existing API, and since libraries provide a new API, they develop new patterns with the existing API. So for example, the DOM API, users, web developers who work with the DOM API develop things in a very specific way. But when you use a library to interface with the DOM, instead, you begin to develop things using new patterns. And sort of my hypothesis is that when you use libraries to change how you interface with specific APIs, it changes and advances JavaScript development in very interesting ways. So specifically, there's been some discussion lately over whether whether you should even create JavaScript libraries. I'm a little bit biased, but I wholeheartedly think that there should be JavaScript libraries and that every user should use them. Specifically, the most obvious reason for creating a library, and this is completely language agnostic, is that you tend to distance yourself from repetition. So if you have code that you want to repeat over and over, you generally extract that out into a reusable set of functionality. In the world of JavaScript, JavaScript libraries also, in addition to removing from repetition, you're also trying to remove the user from the browser differences that exist. Specifically, these can be simply bugs that exist in browsers, or they could be just pure differences in how browsers work. And I tend to argue that this is very similar to how things work in other languages, just in a different capacity. For example, in C, you're trying to distance yourself away from the platform differences, how processors might work. So today I wanted to talk a little bit about the DOM API and how the DOM API has influenced development, and then how JavaScript libraries are tending to change that. So the DOM API is implemented in every modern browser. It's in all of the Yahoo UI A-grade browsers. And it is very, very stable. Generally speaking, if you pick a specific feature out of the DOM API, it's probably implemented in a major browser. And additionally, since it's been around for a while now, it is very well documented. There's numbers of resources that you can go to. There's books on it. It's a very accessible API. So today I'd like to, I have a number of browser differences, if you will, that I think are kind of fun. And specifically, I'm only picking browser differences that are directly related to the DOM API, nothing else. And specifically, I'm trying to make a case for why I feel that libraries are important, even in the case of the DOM, which is very well documented and very accessible. So specifically here, this is a fun one that we discovered in the jQuery camp. In Internet Explorer 7, there was virtually no JavaScript changes. The only change was that they created a new XML HTTP request object that you could more easily do XML HTTP requests. However, they actually regressed in a number of areas. And specifically, this was one of them. If you do get elements by tag name on an object element, it returns an empty set always, and there's no way to get around it. For whatever reason, they broke this chunk of functionality. I'm assuming it's due to the different patent issues that have come up, but I thought this was kind of mind-boggling and interesting. So since get elements by tag name, generally speaking, is a very stable function that you don't expect to misbehave. Additionally, there's Safari 2, which has interesting problems unto itself. For example, if you have a div, let's say, that has visibility, or its display set to none, that tends to affect all elements that are contained within it in very wrong ways. So for example, here's a select box with a single option. And generally speaking, when you have a select box with a single option, whatever the first option will be selected. Its selected attribute will be true. But in Safari 2, if you have a div with display set to none, this selected option is not set to true. It's simply undefined. And this is a case. So the selected attribute is a case of the. This is a sort of what's called DOM 0. What sort of the functionality that predated the existing DOM. But this is a case where this is broken in a modern browser in a very strange way that you or a user may not expect it to be broken. So both of these are cases of genuine bugs. These are bugs in the browser that, this is functionality that's very well defined, but it's broken in some specific, strange sort of way. And these are generally the worst kinds of bugs to deal with, in that they're not documented very well, and they're very obscure, and it makes development as a whole very, very frustrating. In that you don't know why a query, a get elements by tag name on an object element, it just is failing in Internet Explorer 7. And it makes development as a whole much more frustrating. So these next two, specifically that I'm going to show here, are instances where the browsers have taken a different view on how something should be implemented. Specifically, in Opera and IE, or specifically in IE, then Opera followed suit. If you did get element by ID, it also returns an element that has a specific name as what you queried for. So in this case, we're looking for something by element by ID, Q, but instead of returning the element that actually has the ID of Q, it instead returns the input element that has the name of Q. And that can be very, very deceptive, and that you don't expect that to occur. And that's a case where Internet Explorer, they defined how they were going to do it in that specific way. And then Opera, in order to better display Internet Explorer applications, they copied that functionality. And this is another case here. This one's really frustrating. I don't know if you hit this one. If you have an element with an ID of length, Internet Explorer and Opera have what's called expandos, in that they expand properties out into elements, into references to an element. So in this case here, you do get elements by, or get element. I'm sorry, that should be get elements by tag name. Get elements by tag name input, and you would get a set, a node set of all the input elements. However, since one of the input elements has an ID of length, that overwrites the array's length property, meaning that you can no longer iterate through the array, since you don't know how long the array is. And this is hugely frustrating, because someone will present you, like in the case of jQuery, we ran across this one, and someone had a perfectly innocuous form, and you look at it and you're like, there's nothing wrong here. It's a form, there's an input element, what's wrong? And then as it turns out, it's because of these expandos that forcefully overwrite known functionality. So in both these cases, these two browsers have opted to perform in this manner, and at this point, it's so well defined that it sort of from their point of view that changing it would break existing applications, and therefore it's almost a regression at this point. While at the same time, they don't, this particular sets of functionality don't follow a specific specification. They break specifications. So many would consider these to be true bugs, whereas those browser vendors would argue that they aren't necessarily bugs. And then these last two here I find to be pretty interesting. And these are cases where the DOM, the API that's presented with the DOM, operates in a way that the user does not expect. So for example, we have an input element, and we want to disable it. And a user might expect to be able to do set attribute on the disabled attribute and set it defaults. So disabling, or in this case, enabling the form element. When in fact that is not the case at all. And passing in, and this is because passing in a Boolean value is completely, the DOM API doesn't know what to do with Boolean values and attributes. So it just sort of, it won't enable it. And this is another case here, in that a user wants to be able to set a specific class name on the document body. However, so they say set attribute on class, and they will set the class to home. It seems like it would work because that's how they write it in HTML. You say class equals the class name. However, that is not how it works because class is a reserved word in JavaScript. So therefore, you have to use the phrase class name. And this is completely counterintuitive to a normal user. That, because why not just use class? Because that's what it's called. But you can't. And there's many cases of this, like the for attribute. And there's many of them. It's very frustrating. This is a common problem where the user expects an API to behave in a specific way, but it does not. So to recap, the browsers behave in very strange different ways. Some are documented better than others. And this is causing libraries to be created. In that, for example, Internet Explorer has a number of differences and bugs. But generally speaking, they're much better documented than most bugs. And that since Internet Explorer has such a large market share and so many people develop for it, it's the possibility that it'll be documented and written about online is much more possible. Whereas Safari, generally speaking, has less bugs, but the bugs in it are so much more obscure. In that, I found a number of bugs that it'll cause Safari to crash, but people just don't write about it since Safari has such a small market share. And then additionally, so in the case of the last two examples, APIs don't do what the user expects them to. And finally, when in the case, this all sort of compounds together in that when APIs don't do what you expect them to, and when bugs aren't documented well enough for you to understand them, that means that an API is effectively impossible to learn, but through experience. So if the bugs aren't documented and the API doesn't do what you expect, you have to physically use the DOM API in and out every day for months and months, if not years. So what libraries generally do is they break down problems into sort of what I say is meta problems. And so these are generally more encompassing problems, and that they may encompass a number of, for example, in relation to the DOM, it may encompass a number of features relating to the DOM, a couple aspects of the DOM API. So specifically, there's three common meta problems that most libraries have. For example, waiting for the document to load. This is a universal problem in that if you want to manipulate a DOM document, your JavaScript may execute before the DOM document even exists. And again, this is another case where the user doesn't expect that to occur, and it's something that you learn, generally learn through experience. Another one is traversing the DOM, and then finally injecting some HTML into a page at a specific location. So these are all examples of larger problems that people want to tackle, or they want a solution to, that the DOM doesn't immediately present a solution to. So the first one, waiting for the DOM to load. This one's like I said, this is particularly frustrating in that the user does not expect the DOM document to behave strangely when their JavaScript loads. They expect to be able to query it, get elements by tag name, and just have it work. But that's not the case, in that only a part of the document might be loaded, or maybe none of the document is loaded, and their call will just fail outright. The most common option is to wait for the window to load, in which case you would wait for all the images and CSS and external JavaScript to load on the page before finally executing your JavaScript. And this causes horrible problems in that the user might be, for example, if you wanted to focus on an input element, a user might be typing in a field, and then they'll be refocused back to wherever the focus was initially taken. It's things like that make the experience worse for the end user. So specifically, for example, the first snippet here is an example of what I just talked about, where the most common solution is to inject a script, just a small script, right after an input element that calls the element before it and focuses it. So this is a case where you want to have like a login field or a search box highlighted and focused on immediately when the page loads. That's, generally speaking, the most common solution. However, with a recent trend towards writing unobtrusive JavaScript, meaning that you write your code in a way such that you don't mix your JavaScript with your HTML, and you don't mix your CSS with your HTML. So you have your CSS in one location, your JavaScript in one location, and your HTML in one location. And developers who want to write in that manner don't want to have to be able to embed chunks of JavaScript into their page, because that's very counterintuitive. So one solution, for example, this is a jQuery snippet here, but this is a case where jQuery provides a function for waiting for when the DOM is going to effectively be ready to be traversed and manipulated. Yahoo UI in their new release, like it just came out the other day, has a DOM ready function. So in this case, as far as I know, all major JavaScript libraries have this function now, in that you can wait for the exact instant when the DOM is ready, which occurs sometime before when the page is actually shown. So you're able to manipulate the page and affect it in ways before it's ever even rendered. So the second sort of meta problem is looking at traversing the DOM. And this is done in the DOM API presents a large number of properties and methods that you can call to traverse. And this is just a small sample of what you'll need to understand in order to traverse through a DOM document. And again, how that works behaves in very specific ways that the user may not intend. For example, there's all the bugs and differences that I mentioned before. But in addition to that, there's weird things like how white space is handled by a browser. For example, is white space considered to be a text node, or is it just removed entirely? Browsers act differently in that respect. And in that respect, it tends to be very tricky to do what you would expect to. And so what's been happening is that there's been sort of a surgence of DOM, what I call DOM selectors, and that sort of APIs for selecting groups of DOM elements from a document. And so the overall goal of these is to improve how you query through a document, making it easier, making it easier for a user to get up and running right away. So this is a case where you're providing an API on top of the existing DOM API. So the DOM API currently does not provide a way to query through a document. And this is a case where really standards, since the whole problem of querying through a DOM document is very well understood, that we should really look to standards for inspiration of this. Specifically, there's two sort of standards for querying through a DOM document. The first is incredibly well defined. There's the XPath selectors, and these XPath is the querying language for querying through XML documents, and there's hundreds of implementations of XPath, and there's a number of implementations even in browsers. XPath is very well defined, very powerful, but it is not as accessible to, generally speaking, not as accessible to web developers. In that web developers understand, for example, CSS selectors better. So in CSS selectors, this is where you can, if you're writing a style sheet and you want to set up some rules so that specific styles are set, you would use CSS selectors to match specific elements. Unfortunately, we've been kind of stuck in a rut for a long time, in that Internet Explorer specifically hasn't had very good selector support. So because of that, users have been using only the most basic minimum of CSS selectors, which is essentially equates to CSS1, and it's really not very fun. So, but if you look at, for example, CSS3, there is a huge amount of functionality that is specifically tailored to working with HTML documents and making it easier for, theoretically making it easier for web developers to be able to work with HTML documents. So for example, this is an example of 3 different selectors. In this case, it's with jQuery. The first one at the top is a selector using CSS3. So you're matching an element by ID, finding all child li elements, and then finding everything that is not the first child. So I mean, this is if you're not familiar with CSS3, this may seem a little bit foreign, but this is all valid. And what's interesting is that the normal DOM code to write something like that is probably going to be about 20, 25 lines of code. Whereas the user can write this, and it's 1 line, and they can achieve their goal immediately. Obviously, there's implicit performance hits in this respect, but there's a lot that a library can do to make it faster, such as caching or using a native XPath implementation behind the scenes. The second example here, in jQuery supports CSS3, but additionally it supports a little bit of XPath too. So that in the second query, you're looking for all unordered lists that contain another unordered list. Currently, this is a query that cannot be performed in CSS3. And it can only be done in the world of XPath. So because of that, the jQuery selectors are sort of an amalgam of the two. It's mostly CSS3, but it takes some of the good stuff from XPath as well. And the third one is an example of a selector that users commonly want, but that no existing standard provides. So for example, the colon even, so finding every other table row. This is something that users want a lot, and they want to, generally speaking, for striping tables or some such. But neither CSS3 nor XPath provides an easy hook for that. Generally speaking, they're a little bit more obtuse. And again, all of these different selectors here are generally much more complicated to write using nothing but the DOM itself. And instead, you've turned it down into a simple 1-line problem that is much easier for a developer to understand. The third problem is that libraries like to solve is injecting HTML into a page. So effectively taking an HTML snippet and inserting it into a page at a specific location. This it seems like it would be a simple thing to do, but it's incredibly frustrating. in that how browsers deal with specific elements, it varies so wildly between them. For example, inserting table rows or inserting options into a select box. All these things, it feels like they should work, but they don't, and in ways that are very non-intuitive. So the solution is to provide a mechanism to allow the user to write HTML and then be able to insert it for them. And the way this works is you take the HTML string from the user and you convert it to DOM nodes on the fly. And this can be a little bit tricky, but the way it works is, for example, for an option element, for example. You take the option element and then you wrap it in a select, inject that into the DOM, and then extract it back out again and take out the DOM nodes. And then you take those DOM nodes, which are nice and clean, and you can insert them anywhere into the document. So this way is, I'd say, about 98% foolproof, and that it works quite well, and that does what the user expects it to. It gets a little bit tricky when you start dealing with XML documents and inserting things into that, but that's something else entirely. So what's interesting is that when you have these three technologies together, so when you have a way to wait until the DOM is ready, you have a way to use selectors to traverse through a document, and you have a way to do HTML injection, you effectively have a way of doing really good unobtrusive scripting. So like right here, this code, it waits for when the document is ready at the exact instant, finds all selects, and adds a new option to them. And what's interesting is that you could look at that and say, all right, well, that would only be, I don't know, 20 lines of code. It wouldn't be that bad. However, the knowledge that you must know in order to write that 20 lines of code, to know that the document isn't going to be ready right away, to be able to foolproof, doing get elements by tag name, and be able to inject an option in a specific location, is much larger than any amount of code that you write. And so because a library can remove a user from having to deal with those frustrations and those cross-browser incompatibilities, the user can start to perform in a much better way and be able to worry less about, will this work or not, and just worry about programming. Now, what's interesting about all of this is that, as I mentioned before, when users use the DOM API, they behave in a specific manner. But now when they use this new API that is theoretically better, it causes the user to have new expectations about how things might work. So this is a really interesting one that I've encountered in the jQuery community. Specifically, a user will write a query, such as finding all li elements that are a child of a ul element, and attach a click event that when that li is clicked, it'll load a menu from an external file. And in that external file, it'll just be a chunk of HTML. So this is a menu here where you'll click and a new submenu will pop out, and you click again and a new submenu will pop out, and you'll continue through. But what happens is that users expect something very different to happen. If you look at that and you look at the new submenu that's appearing, at least when I first looked at it, a user expects that that when they click on a child menu, that it actually pops out, and then they can click on the child menu again, and it can pop out. So they can keep doing this. But like when the first user came and it said that, look, it's failing. This is a problem with jQuery, and I looked at it and I said, no, that's not a problem at all. The selector only runs once. It runs when the page loads, it attaches the events, and you never ran the selector again. But the problem is that users are expecting the selectors, the DOM selectors in this case, to behave more like CSS. And that in CSS, if you write a CSS rule that sets a specific color, and then you add in a new element to the page, that new element will also be affected by the original rule. You don't have to like rerun the rules again. And because of that, because of this construct exists, users expect the events that they've bound to propagate through and be bound down in, even when they load new chunks of HTML into a document. And this is interesting because when I first thought of it, when I first looked at it, I was like, wow, that's really counterintuitive. And it seems like that would be something that would cause a lot of unintended consequences. However, once we started to look at the problem more, we realized that this is something that was never really intended for the original DOM API. But now that there's a library there that's introducing this functionality, users are expecting it to behave in a specific manner. And that's a really interesting thing because now you're looking at JavaScript and DOM development in a completely new way. So sort of a new pattern emerged out of this that we generally call behaviors. And specifically, so what you do is you provide an initial hook that for when the page loads, you attach a click event to everything that's currently in the document. And then additionally, whenever a menu loads, you recall the handle click function and rebind everything that you just loaded. It's not perfect in that, meaning that this isn't something that a first-time user could probably pick up. But if you distill it down into a single function, such as, so instead of binding a click event, you're now attaching a click behavior. Maybe the user now expects it to behave in a specific way. And now the code has been reduced to effectively 5 lines. But in this case, it behaves in a manner that is more intuitive to them. And then as an example here is the DOM code to effectively do what that previous snippet did. And that you, waiting for window on load, go through and you find all the LIs, and then you attach the click events, and finally do the XML HTTP requests, retrieve the document, inject it in. And again, that's 20 lines there? It's not too bad, but when the issue comes into play is when all the problems come in. And for example, attaching an event listener, so using add event listener, that doesn't exist in Internet Explorer. And specifically, when you have a callback for a function, for an event listener, sorry, an incorrect context is set on that event listener in Internet Explorer. There's no XML HTTP request in IE6. The onReadyState function leaks horribly in Internet Explorer. Window on load doesn't occur right away. It happens at a delay, and maybe the users tried to click before the document's ever loaded, and it doesn't work. So these are all problems that are sort of domain knowledge that you learn over time. Some of these you'll probably be able to learn from a book or a website, but a lot of them, the only way to learn them is by repetition and by doing. And because of that, it makes regular DOM scripting really, really frustrating. So another example is about the Fuel library that I'm working on at Mozilla. And specifically, this is a library, a pure JavaScript library that is meant to be used for Firefox extension development. How many people here have tried to develop a Firefox extension? All right, then you probably know how painful it is, because it's, at least coming from a web development background, it's really, really frightening. The problem is that the current API and a way of doing things is all C++ and XPCOM, and granted, you can do a lot of it in JavaScript, but the APIs that are available were written by C++ developers. And it is very counterintuitive to a web developer. So for example, let's say you want to set a Firefox preference, so a Unicode preference in Firefox. All you're doing is setting one value. This is the code that you would need to do that currently. This is using XPCOM, and it's 1, 2, 3, 4, 5, 6, 7 lines of code. And it's incredibly daunting. This is pretty insane, quite frankly. So for example, in Fuel, we distill that down to an API that is more tangible. So this is what you would be able to do with Fuel. You can set a value in preferences to some non-ASCII value, and the system implicitly figures that out, and figures out that it's non-ASCII and sets it correctly, and it handles everything that stuff that probably should have been done to begin with, but it didn't, and now here it is. So this is going to be in Firefox 3, and hopefully it'll make extension development considerably easier. And as another analogy, I wanted to show a very common example, just to show that this isn't exclusive to JavaScript development. That reading new patterns and new APIs is not exclusive to JavaScript development. So for example, with SQL, you want to do a very basic SQL query. For example, selecting a user with a specific ID out of a table. That's really straightforward. And then on top of that, there's another API. So for example, if you want to query SQL from PHP or Perl, in this case PHP, you would do this specific query. And that's after having already connected to the database and initialized everything. You would do a query like that, and then iterate through. And then finally, what's been happening is that you have these new object relational mappings, and that this is an entirely new abstraction layer away from SQL and away from programming interfaces. So you can now write things like this, user.find5. And that allows you to write code that looks like this. Oops. So this is Ruby here. But this is so far removed from the actual writing of SQL that you can barely even see the SQL anymore. I mean, you could see it if you thought about it, but I mean, it's incredible. I find this to be incredibly interesting because this is a case where by providing object relational mapping, it has absolutely exploded the popularity of Ruby on Rails. And by having these intricate hooks and allowing users to write stuff like this. For example, my favorite line is the second line, has many people. So in this case, an account has many people. That is, it's pure English. You're writing in English words, but the work that's going on behind the scenes is so phenomenal that, like I said, you can barely even see what is happening way down the chain. And I think this is really interesting in that, a SQL purist, as mentioned before, my background's in data mining. It's really upsetting at first. You're like, oh my goodness, this is going to be run so slow, and like how can people use this? But then you realize that that maybe that's not such a bad thing, and that yes, it will run slower, but it'll phenomenally change how development works and how you develop applications. And especially for new users who are just getting started, this is incredibly useful. So, in conclusion, I just wanted to say that, to recap and say that, libraries create new patterns on top of existing APIs. And so even though that effectively, for example, a JavaScript library is still just using the DOM underneath, the users are starting to think in entirely new ways that is starting to affect and hopefully improve their development. And that libraries are helping to advance development in really considerable ways. So I have 10 minutes? All right, really quickly. I want to do something really cool. So in this case, this is what I call meta libraries. In the case where a library has become abstracted enough that at the point where you can begin to write domain-specific languages. So you can begin writing a programming language that is based upon an API, such as jQuery, that is based upon a DOM API. So for example, I just want to show it real quick. So here, I called it jQuery 2. It's not going to be the second version of jQuery, I can tell you that. This is sort of a very unique, in that, let's move it to the right a little bit. This is a programming language and syntax that I invented in an afternoon of hacking. And what it does is it compiles down to JavaScript code, and specifically jQuery code. So if we compile this, scroll down, so you can see it gets built down into a parse tree, and then it turns into some really ugly looking jQuery code. But the point is that you can write your code in, syntactically, there's very few characters there. I mean, above, you're writing, pre.run, append, and then a value. I mean, as far as syntactic sugar goes, you have 1, 2, 3, 4, maybe 5 characters, and that's really considerable. And it actually works, and it works in a very fun way. If you look up here, this page is running off of. If you look at the script tag, the third one down, the type is text/jQuery. And what this means is that browsers don't know how to run scripts of a type that they don't understand. So what browsers do is they just ignore the script and assume that you made a mistake or something. But what happens is since they've ignored the script, you can run back through later with, let's say, parse.js. So when the document loads, go back through, compile it down to JavaScript, and then execute the JavaScript immediately. So in this case, the whole page is running. So like when you click the compile button, this code is running. So it's finding the first input, and then when a click occurs, the compile function is running. So I think this trend is only just starting to occur, and that there are now libraries that allow you to write Lisp, for example, in a script tag. It just came out like this past week. So if you're so inclined to write Lisp in your browser, you could do that. But I think this is a really interesting development. I don't know where it'll lead, or even if it's very fruitful, but I think it's a really interesting result. So while we still have some time, I'd like to take some questions. So let me just. So yeah, so there's more information. So you find out more information about Fuel. 0.1 is landing in the trunk, Mozilla trunk here, probably this week. And then we're working on 0.2 right now, which can have stuff like browser tabs and bookmarks and stuff like that. So yeah. So the question was, does Fuel require Firefox 3 to run? Currently, our very first release does require it to run. But we definitely want to backport it to older versions of Firefox. And additionally, make it so that you could just theoretically drop it in your extension and have it just work. So if you were developing an entirely new extension that you only cared about running on Firefox 3, let's say Firefox 3 was already out, then in that case you wouldn't have to worry about it since it would already be there for you. So the point was, if the selectors were not in fact CSS selectors and something entirely different, maybe then the users wouldn't expect it to always, to propagate through the document. It's very possible. I mean, if it was an XPath implementation, it's very feasible that users would not expect that at all. Of course, the users who know and can use XPath, I assume are in a little bit of a different league. What I find interesting about jQuery is the number of users who are completely designers, in that they have never written a line of code ever, whether it be JavaScript or any other language. And so jQuery is ending up being their first experience to programming. And so, this is where, this sort of preconceptions come from. And I don't think that's necessarily a bad thing, in that, because since the user expects it to happen, why shouldn't it happen? You have to sort of think it over. Maybe it shouldn't happen, but at least it gets you thinking in a different way. Okay, so the question was, how do you support like adding a new feature that might be really fast in Firefox and then really slow in IE? And I guess that almost that even comes down to maybe it works in Firefox but fails in Opera, or it works in all browsers but Opera theoretically. I mean, it's sort of the same situation in that the approach I've been taking to development, and specifically with jQuery, is that I would rather have a smaller set of features that work 100% consistently, and in this case, performantly, across all browsers, than a large API that is kind of waffly all around. And because of that, the jQuery, we've been keeping the API incredibly small. In jQuery 1.1, we reduced the API by about 40%. I don't know many JavaScript libraries that are actively reducing in size and removing code. So I mean, we're a little bit different in that we actively try to make things simpler, and in this case, we try to keep things as consistent as possible, even down to speed. So the question was, how do you deal with caching DOM nodes from selectors? And out of all the libraries that exist that implement a selector engine, none of them do pure result caching. Because the problem is that, and this is more of a feature that it's impossible to implement. For example, if you do get elements by a tag name and you store that as a result, that's a live result, meaning that if you add a new element into the page, that array is gonna, it's not an array, it's a node set, will be updated live with new results as they come in. And that's a feature that if a JavaScript library were to implement it, it would just devastate the browser, because you'd have to be querying the entire DOM all the time to see if anything new gets added. So the issue is that generally the way we approach caching at jQuery is that you end up writing code that is we ask that users store things as variables. So for example, so if a user finds all inputs with a specific class, they can save that to a variable. Then later on, they can say, foo, and then .find something something that's inside of, well, there's nothing. I guess there's nothing made in an input, so form. Then find all inputs that are required or something. So I guess the approach we take to caching is that currently is that you should break down your queries as much as possible, store them for later, and then that way later on you can run them again, and the results are already cached and pre-run. It's not ideal in that it'd be awesome if there was crazy caching and live updating, but I guess that's more of a case where having a pure browser implementation would be ideal. So the question was, that generally speaking, Firefox, if there's an extension that does things that are not performant and has memory leaks and stuff, you'll feel that in Firefox because the extension's going bonkers. And so the question is that now that Fuel is coming out and more extensions are coming out, what's going to occur? And specifically, what's nice about being able to have a JavaScript library like Fuel is that you can do the best practices in Fuel, and the users can just use that API and know that they're doing the best practices. So, and I think that has more to do with the fact that how things currently work with XPCOM and just all the different weird APIs that users simply just don't understand how they work. Therefore, they can't code to best manage memory. I don't feel that memory management should be a huge issue for a JavaScript developer. In that, or I should say, for your average web developer, it should not be a huge issue, and that should be something that should be implicitly be taken care of. So that is absolutely something we're looking at. And all throughout Fuel, we're trying to do the best practices. And even then, even if a user wants to advance beyond Fuel, they can just crack open the code, since it's just JavaScript, and look at seeing how we do it. How do you reduce backward compatibility issues when you reduce the size of an API? In our case, we jQuery has a plugin architecture, so you can snap plugins in, and it extends how jQuery works. So when we released jQuery 1.1, which removed 40% of the API, we released a compatibility plugin, which reintroduced everything back in. But at least someone then can migrate from 1.0 to 1.1 fairly pain-free, in that they could just include that one plugin, and then once they've removed all the code, they could take that plugin back out, and things would work. That works for most things. There was one case where we had, in our CSS selector implementation, nth child in CSS begins at 1 instead of 0. We started at 0 instead of 1, because we're like, it starts at 0. Of course it starts at 0. But it actually starts at 1 instead of 0. And so we had to make that switch. And I think that was the hardest switch. And that's something that is more likely to break things. So yeah, I think that's it. Thanks for having me.